Above the Dutch countryside near Eindhoven, at an altitude exceeding 14,000 feet, the morning of September 17, 1944, unfolded with a spectacle of military might that would have been unimaginable just a few years prior. The day marked the commencement of what historians would record as Operation Market Garden, and with it came the largest deployment of airborne forces the world had ever witnessed. Thousands upon thousands of Allied aircraft filled the skies, their formations stretching across the horizon as they supported the massive paratrooper insertion that would define this ambitious offensive. Among these countless machines prowling the airspace above the designated landing zones flew entire squadrons of Republic P-47 Thunderbolts, their distinctive silhouettes unmistakable even from a distance. What made these particular aircraft so remarkable on this particular day was not merely their presence, but rather what hung beneath their wings and fuselages. Each of these American fighters carried an impressive array of ordnance, bombs and rockets that collectively weighed approximately 2,500 pounds per aircraft. For the German pilots of the Luftwaffe who scrambled their aircraft in desperate attempts to intercept this aerial armada, the sight before them represented something they had fundamentally failed to predict or prepare for. These same American fighters, which German intelligence had systematically dismissed and underestimated barely 18 months earlier, now demonstrated a capability that seemed to defy the very principles upon which the Luftwaffe had built its tactical doctrine. The bomb load carried by each individual P-47 represented roughly half of what a Boeing B-17 Flying Fortress typically carried on its long-range strategic bombing missions. This wasn't some experimental modification or special circumstance. This had become standard operational procedure for these American fighters. A single-seat, single-engine aircraft, flown by one pilot, could now penetrate deep into contested airspace, engage enemy fighters if necessary, deliver a devastating payload of bombs upon ground targets, and then fight its way back to friendly territory. The transformation that had occurred was nothing short of revolutionary. The evolution of the P-47 Thunderbolt from its original conception as a pure air superiority interceptor into what would become the European theatre's most effective and feared fighter bomber didn't merely alter tactical considerations or modify operational procedures. It fundamentally changed how military strategists thought about air warfare itself. This transformation would play a crucial role in accelerating the collapse of Wehrmacht resistance and would establish doctrinal principles that would influence military aviation for generations to come. What the German High Command and their Luftwaffe technical experts never anticipated was that American industrial pragmatism combined with operational flexibility had created something unprecedented. This wasn't simply a fighter aircraft that could occasionally carry bombs, nor was it a bomber that could defend itself. It was an entirely new category of combat aircraft, a truly universal platform capable of performing virtually any mission profile at any given moment, switching between roles with devastating effectiveness, depending on what the tactical situation demanded. When the P-47 Thunderbolt first entered active combat operations in April of 1943, many observers, particularly those within the Luftwaffe's intelligence apparatus, believed their initial assessments about American aircraft design philosophy had been thoroughly vindicated. The aircraft seemed to embody every stereotype about American engineering. Massive, incredibly powerful, built with brute force rather than elegant finesse. The 4th Fighter Group flew the type's inaugural official combat mission on the 8th of April 1943, and German intelligence officers who subsequently analyzed reports about this new American fighter reached conclusions that aligned perfectly with their pre-existing assumptions about how the Americans approached aircraft design. The raw technical specifications alone seemed to suggest an aircraft of questionable effectiveness, at least when evaluated according to the standards that German engineers considered most important. The sheer weight of the P-47 was staggering by contemporary fighter standards. Empty, without fuel, ammunition or pilot, the aircraft tipped the scales at approximately 10,000 pounds. This was literally double the empty weight of the Messerschmitt Bf-109G, which at that time represented Germany's primary single-engine fighter. At the heart of this massive airframe sat an equally massive power plant, the Pratt & Whitney R2800 Double Wasp. This 18-cylinder radial engine initially produced 2,000 horsepower, though later variants would push this figure to 2,300 horsepower, and eventually, with water injection and other modifications, some versions would achieve an astonishing 2,800 horsepower. This enormous engine had to propel an airframe that seemed almost deliberately designed to challenge every principle of aerodynamic efficiency that German engineers held sacred. The bulbous fuselage, necessary to accommodate the large radial engine and its associated cooling systems, presented a frontal area that seemed more appropriate for a light bomber than a supposedly agile fighter aircraft. The initial combat encounters between P-47s and Luftwaffe fighters did nothing to challenge German assumptions about the aircraft's limitations. In fact, these early engagements seemed to confirm everything the technical analysts had predicted. The P-47's combat radius in its initial operational configuration barely exceeded 125 miles, a severely limiting factor that prevented it from providing effective escort for bomber formations on most of their deep penetration missions into German-held territory. The aircraft's rate of climb lagged noticeably behind that of German fighters, putting P-47 pilots at a disadvantage in many tactical situations. Perhaps most significantly, when forced into turning engagements at medium altitudes, the battlefield conditions where much of the air combat over Western Europe took place, both the Focke-Wulf 190 and the Bf 109 demonstrated clear performance advantages. The P-47's tremendous weight, which German pilots quickly learned to recognize and exploit, became a significant liability in these circumstances. German tactical doctrine evolved rapidly to take advantage of these perceived weaknesses. Experienced Luftwaffe pilots developed specific techniques designed to force the heavy American fighter into exactly the kinds of combat situations where its weight would work against it. They would attempt to draw P-47s into sustained turning battles, where the lighter German fighters could outturn their opponents. They would use vertical maneuvers, climbs and dives that required rapid changes in energy state, where the P-47's momentum became a hindrance rather than an advantage. These tactics worked, at least initially, and German pilots scored victories against P-47 units throughout the summer and fall of 1943. What the Luftwaffe's technical experts and combat analysts fundamentally failed to grasp, however, was that they were observing something quite different from what they thought they were seeing. They were watching a heavyweight boxer in the early rounds, an aircraft being employed in ways that barely scratched the surface of its true potential. A weapons system whose most significant capabilities would not be fully exploited or even fully understood for another year. The very characteristics that German analysts had identified as weaknesses, that robust construction requiring heavy steel tubing and extensive armor plating, actually provided the foundation for capabilities that would prove revolutionary. This structural strength allowed the aircraft to absorb battle damage that would have destroyed lighter fighters. More significantly, it meant the airframe could handle extraordinary external loads without structural failure. The wing pylons, those hard points originally engineered solely to carry external fuel tanks for extending the aircraft's operational range, had been built with engineering margins far exceeding their initial intended purpose. These mounting points were capable of carrying up to 2,500 pounds of external ordnance, a load that would have literally torn the wings from most contemporary fighter aircraft if anyone had been foolish enough to attempt such a thing. Republic Aviation's chief designer, Alexander Kartveli, had built tremendous safety margins into every aspect of the aircraft's structure. Margins that would prove crucial as the P-47's role evolved in ways that nobody, including Kartveli himself, had fully anticipated during the initial design phase. The transformation of the P-47 from pure fighter to fighter bomber didn't begin with some grand strategic vision articulated by high-ranking officers at headquarters. Instead, it emerged from pragmatic adaptation by combat pilots who recognized opportunities when they saw them. As 1943 progressed and P-47 squadrons flew increasingly frequent bomber escort missions, pilots returning from these operations began taking advantage of opportunities that presented themselves on the return flight. With ammunition remaining and fuel sufficient to loiter briefly, they started attacking targets of opportunity on the ground. Railway locomotives presented particularly attractive targets, large, relatively undefended, and extremely vulnerable to the P-47's formidable armament. Truck convoys travelling along roads, fuel storage depots, supply dumps, all of these became regular targets for P-47 pilots who had completed their primary escort mission and had ordnance remaining. The results from these impromptu ground attack missions proved immediately and dramatically promising. The P-47's standard armament consisted of 8 Browning M250 caliber machine guns, each one capable of firing approximately 800 rounds per minute. When all 8 guns fired simultaneously, which they typically did during strafing runs, they could deliver 12.7 pounds of lead per second into the target area. This was sufficient firepower to penetrate a locomotive's boiler, causing catastrophic explosive failure. It could shred a truck convoy, turning multiple vehicles into burning wrecks in a single pass. It could ignite fuel storage tanks, creating secondary explosions that destroyed entire depot complexes. The effectiveness of these attacks didn't go unnoticed by squadron commanders or by higher headquarters. The first official modifications to allow P-47s to carry bombs came in November of 1943. Engineering teams installed specialized bomb shackles, rated to carry 500-pound bombs, on both the belly centerline and the wing pylons. On November 25, 1943, the 62nd Fighter Squadron conducted what would be recorded as the first official P-47 bombing mission. The target was a Luftwaffe airfield located at Saint-Omer, France. 8 Thunderbolts participated in this raid, each one carrying 2 250-pound bombs. The mission achieved notable success, destroying 2 hangars completely and damaging 5 German aircraft that had been parked on the ground. This single mission demonstrated that the concept was viable and that P-47s could effectively deliver bombs against tactical targets. Throughout the winter months of 1943 and into early 1944, Republic Aviation's engineering teams worked in close cooperation with United States Army Air Force's technical services to accelerate and refine the P-47's transformation into a true multi-role aircraft. Engineers reinforced wing spars to handle the asymmetric loading conditions that occurred when bombs were released from one side but not the other. They developed sophisticated electrical systems for bomb release mechanisms that had to function reliably whether the aircraft was operating at 30,000 feet in sub-zero temperatures or at treetop level in the heat and dust of a ground attack run. They created specialized gun sights, including the advanced K-14 computing gun sight that could automatically calculate proper bombing angles for both dive bombing and glide bombing attacks, significantly improving accuracy. By early 1944, the modifications being implemented had progressed far beyond the simple addition of bomb racks. The M8 4.5-inch rocket had been adapted for use on fighter aircraft. Each of these rockets packed destructive power equivalent to a 105mm artillery shell. A single P-47 could carry 10 of these rockets plus 2 1,000-pound bombs simultaneously, giving it more explosive firepower than many twin-engine bombers had carried in the early years of the war. The transformation was complete. The P-47 had evolved from a pure interceptor into a devastating ground attack platform while retaining its formidable air-to-air combat capabilities. The 6th of June, 1944, D-Day, the Allied invasion of Normandy, marked the moment when the Luftwaffe leadership finally and comprehensively grasped what the P-47 had become and what it meant for German defensive capabilities. On that single day, across the invasion beaches and the surrounding countryside, P-47 Thunderbolts flew 1,985 individual sorties. They dropped 525 tons of bombs onto German defensive positions. They fired 135,000 rounds of .50 caliber ammunition at ground targets. The confirmed destruction reports documented by Allied intelligence made for sobering reading in German headquarters. 86 locomotives destroyed, eliminating the ability to move reinforcements by rail. 507 motor vehicles destroyed, decimating supply columns. 38 gun positions eliminated, reducing defensive fire against the invasion forces. 17 fuel dumps destroyed, crippling the mobility of German armoured units. The aircraft that German intelligence had categorized just a year earlier as a mediocre high-altitude interceptor, unsuited for ground attack work, had become the workhorse of tactical air power in the European theatre. Günter Rall, who would finish the war as one of history's highest-scoring fighter aces with 275 confirmed victories, encountered P-47 Thunderbolts repeatedly throughout 1944. His experiences fighting against these American fighters gave him a perspective that differed markedly from the assessments being produced by intelligence analysts who never faced the aircraft in combat. In an interview conducted in 1996 with HistoryNet, Roll reflected on his experiences. He explained that the P-47, which had shot him down, possessed characteristics that German pilots immediately recognized and respected. It had tremendous diving speed and could reach velocities approaching 1,400 km per hour in a dive, while the Bf-109 was structurally limited to approximately 1,000 km per hour. Roll learned this limitation the hard way when P-47s pursued him, and he discovered that diving for safety, usually a reliable escape technique, simply didn't work against these particular opponents. On May 12, 1944, Rall's luck ran out during an engagement with P-47s from the 56th Fighter Group. In the fierce combat that followed, he was shot down, suffering severe injuries including the loss of his left thumb. His damaged flying glove, still stained with blood from that encounter, is now displayed as a historical artifact at the National Air and Space Museum in Washington. After Germany's surrender, Roll was recruited to fly captured Allied aircraft at the German Fighter Leaders School, where former Luftwaffe pilots evaluated American and British aircraft to understand their capabilities and limitations. Rall flew P-47s for approximately 300 hours in this capacity, gaining an intimate understanding of the aircraft that had defeated him in combat. This extensive experience only reinforced his respect for the Thunderbolts' capabilities. The P-47's ability to instantly transform from bomber configuration to fighter configuration created a tactical problem for the Luftwaffe that proved impossible to solve effectively. German fighters would be vectored to intercept what appeared to be vulnerable fighter bombers, laden with external ordnance and presumably focused on ground attack missions. When Luftwaffe pilots engaged these formations, they frequently discovered that the P-47s could simply jettison their bombs, instantly transforming back into pure fighters with superior firepower and remarkable structural durability. The psychological effect of this capability was significant. German pilots never knew whether they were engaging bombers or fighters until the engagement was already underway. The statistics describing the P-47's payload capacity created mathematical calculations that German logistics planners found deeply troubling. A standard P-47 D-25, the variant that became the most common in operational service, could carry various bomb configurations depending on mission requirements. 2 1,000-pound bombs provided maximum destructive power for hardened targets. 3 500-pound bombs offered flexibility for attacking multiple targets. Various combinations of bombs and rockets totaling 2,500 pounds allowed mission planners to tailor the loadout to specific tactical situations. This 2,500-pound capacity represented 62.5% of a B-17's typical operational load of 4,000 pounds on long-range missions. This was the basis for the reasonable statement that a P-47 could carry half a flying fortress's bomb load, at least in terms of the typical operational loads being flown by B-17's during most combat missions. The efficiency differential between P-47 fighter bomber operations and strategic bomber operations was stark and undeniable. A squadron of 16 P-47s could collectively deliver 32,000 pounds of bombs in a single mission, equivalent to 8 B-17 operating at typical combat loads. But unlike heavy bombers, which flew from bases in England and could typically mount operations twice weekly due to weather, crew rest requirements and maintenance needs, P-47s operated from forward airfields much closer to the front lines and could fly 3 missions per day when conditions permitted. The mathematical implications were staggering. A single P-47 squadron could theoretically deliver more bomb tonnage in a single day than a heavy bomber squadron delivered in an entire week. The efficiency comparison extended beyond simple tonnage calculations. One P-47 carrying 2 500-pound bombs required 1 pilot and a minimal ground crew consisting of perhaps 4 to 6 enlisted men to fuel, arm and maintain the aircraft. One B-17 carrying 4,000 pounds of bombs required 10 aircrew members, including pilot, co-pilot, navigator, bombardier, flight engineer, radio operator and 4 gunners. The ground support requirements were even more disparate, with each B-17 requiring specialized crews for engines, structures, armament and electronics. The fighter bomber delivered significant destructive power with a fraction of the manpower investment required by strategic bombers. August of 1944 brought perhaps the most devastating demonstration of P-47 fighter bomber effectiveness during what became known as the Falaise Pocket Operation. German forces, trapped in a contracting pocket between advancing Allied armies, attempted desperately to escape encirclement. Between August 12th and August 21st, these retreating German units faced continuous attack from P-47s operating in carefully orchestrated shifts from dawn until dusk, maintaining constant pressure on any forces attempting to move during daylight hours. The authenticated destruction claims from the Falaise Pocket operations, verified through ground reconnaissance after the area was secured, documented industrial-scale destruction. On August 13th, 112 tanks were confirmed destroyed. On August 14th, 287 motor vehicles were confirmed destroyed. On August 15th, 42 locomotives were confirmed destroyed. On August 16th, 89 horse-drawn vehicles were destroyed, demonstrating that even the most primitive transportation was not safe from aerial attack. The 9th Air Force's P-47 groups implemented a relay system that proved devastatingly effective. As one squadron exhausted its ammunition and fuel, fresh squadrons arrived to maintain constant coverage over the pocket. This meant that German forces attempting any daylight movement faced immediate attack, with no respite or safe period during which movement might be possible. Post-battle analysis conducted by Allied intelligence officers who examined the pocket after its capture revealed that approximately 1/3 of all German vehicles destroyed in the pocket were attributed to P-47 attacks. The scale of destruction was unprecedented in the history of tactical air power. The development of the high-velocity aircraft rocket, known by its acronym HVAR, added yet another dimension to the P-47's offensive capabilities. These 5-inch rockets, each carrying a 60-pound warhead, possessed sufficient penetrating power to destroy any German tank's armour, including the formidable Tiger and Panther tanks that had proven difficult to defeat with standard anti-tank weapons. A full salvo of 10 HVARs delivered destructive power equivalent to a battalion artillery barrage, but delivered by a single aircraft in a single attack pass. The 362nd Fighter Group pioneered systematic rocket attacks against German armoured vehicles. Their after-action reports meticulously documented the techniques they developed. Diving from an altitude of 5,000 feet at a 30-degree angle, releasing rockets at 1,500 feet altitude, pilots achieved direct hits on 30 to 40% of launches. This accuracy rate far exceeded what could be achieved by artillery firing at armoured targets, even under ideal conditions. The Battle of the Bulge, Germany's last major offensive operation in the West, which commenced in December of 1944, demonstrated that the P-47 had evolved into an effective all-weather fighter bomber capable of operations under conditions that grounded most other aircraft. Despite freezing fog and snow that reduced visibility to near zero and created hazardous flying conditions, P-47s, equipped with British-developed rocket rails and improved instrumentation, continued flying missions. When the weather briefly cleared on December 23rd, allowing intensive air operations, P-47s flew 647 sorties in that single day, claiming over 400 vehicles destroyed. The cumulative statistics from the period between December 23rd and December 27th, 1944, revealed the P-47's impact on German offensive capabilities. 201 German tanks were confirmed destroyed, eliminating armoured spearheads that were essential to the offensive's success. 1,930 motor vehicles were destroyed, crippling logistics. 953 horse-drawn vehicles were destroyed, eliminating even primitive transportation. 89 locomotives were destroyed, preventing rail movement of reinforcements. 512 rail cars were destroyed, eliminating stockpiled supplies. 47 bridges were damaged or destroyed, preventing movement of reserves. January of 1945 revealed yet another P-47 capability that had not been anticipated in the original design specifications. Precision bridge destruction using 1,000-pound bombs delivered in steep diving attacks became a specialty of several P-47 units. The 56th Fighter Group developed specialized techniques for destroying Rhine River bridges that had survived repeated heavy bomber attacks. 8 P-47s diving from 8,000 feet in 60-degree dives could deliver bombs with 50-foot accuracy, far exceeding the precision achievable by high-altitude heavy bombers, which were fortunate to place bombs within 1,000 feet of their aim point under ideal conditions. The deployment of the Messerschmitt Me. 262 jet fighter in early 1945 should have fundamentally altered the tactical balance in the Luftwaffe's favour. With a speed advantage exceeding 100 miles per hour over P-47s, these revolutionary jets seemed immune to conventional interception. The Me-262 could engage and disengage at will, attacking when conditions favoured the jet and simply accelerating away when circumstances became unfavourable. But the P-47's evolution into a highly effective fighter bomber created an unexpected vulnerability in the jet fighter program. Me-262's required long concrete runways for takeoff and landing. Their jet engines consumed fuel at prodigious rates, and their operational bases became obvious and vulnerable targets for fighter-bomber attacks. On March 21, 1945, P-47s of the 365th Fighter Group caught an entire starful of Me-262s from Jagdgeschwader 7 during takeoff operations from Leipheim Airfield. The jets, accelerating down the runway during their takeoff roll, couldn't maneuver or achieve the speed necessary to escape the diving P-47s. 8 Me-262s were destroyed in approximately 5 minutes, more jet fighters than the overstretched German aviation industry could produce in an entire week. This single attack demonstrated that technical superiority meant nothing if the superior aircraft couldn't operate safely. March of 1945 witnessed Operation Clarion, the systematic destruction of Germany's remaining transportation network by Allied fighter bombers. P-47 units were assigned specific geographic sectors with orders to destroy anything that moved or could potentially move. The goal was complete paralysis of German logistics. On March 22nd alone, P-47s claimed 89 locomotives destroyed, eliminating rail transport capacity, 1,026 rail cars destroyed, eliminating stockpiled supplies, 155 motor vehicles destroyed, eliminating road transport, 17 bridges dropped, severing transportation routes, and 93 rail cuts where tracks were severed completely. The cumulative effect was the complete collapse of Germany's ability to move supplies or reinforcements. The P-47's continuous transformation required constant innovation at every level. The P-47 D-25 variant, introduced in mid-1944, incorporated numerous improvements that reflected lessons learned from combat operations. Reinforced wings were stressed for 3,000-pound external loads, exceeding the original design specifications. Universal bomb shackles accepted both British and American ordnance, providing operational flexibility. Zero-length rocket launchers reduced aerodynamic drag. Improved oil cooling systems allowed extended low-altitude operations without engine overheating. Paddle blade propellers provided better acceleration. Water injection boosted power output to 2,800 horsepower for short periods. The K-14 computing gun sight provided accurate bombing computations. Each of these improvements represented responses to specific operational requirements identified by combat squadrons. Republic Aviation's production facilities at Farmingdale, New York, and Evansville, Indiana, demonstrated remarkable production flexibility throughout the war. Peak production reached 35 aircraft per day, an astonishing figure for such a complex weapons system. 28 major variants were produced during the P-47's production run, each incorporating specific improvements or modifications. 430 field modification kits were developed, allowing existing aircraft to be upgraded with new capabilities without returning to the factory. Perhaps most remarkably, the plants maintained continuous production for 48 months without ever stopping the assembly lines for major redesign work, a feat unmatched by any other fighter manufacturer during the war. Transforming P-47 pilots from fighter specialists focused primarily on air-to-air combat into true multi-role combat aviators required revolutionary changes in training approaches. The United States Army Air Forces established comprehensive training programs that required 200 flight hours, minimum before pilots were declared combat ready. This training included 50 practice bombing runs against ground targets, 20 rocket firing passes, 100 strafing runs, 40 hours of instrument flying, and 30 hours of formation flying. This comprehensive training regimen contrasted sharply with late-war Luftwaffe pilot preparation, which had declined catastrophically to just 110 flight hours before combat deployment, with no fighter-bomber training whatsoever included in the syllabus. American pilots graduated from this intensive training program demonstrated competence across a remarkable range of mission types. They could conduct high-altitude bomber escort missions, engage in medium-altitude air combat, perform low-level navigation to find ground targets, execute dive bombing attacks, conduct skip bombing against shipping or bridges, perform glide bombing attacks, fire rockets accurately against ground targets, deliver napalm weapons, and conduct ground strafing attacks. Individual pilots could transition between these different mission profiles as circumstances demanded, sometimes flying multiple mission types during a single sortie. February of 1945 saw the introduction of napalm bombs carried by P-47s, adding incendiary attacks to the fighter bombers' already impressive repertoire. The 150-gallon drop tanks, filled with jellied gasoline and fitted with detonators, created weapons that could incinerate entire city blocks or large forest positions in minutes. The 362nd Fighter Group first employed napalm operationally on February 14, 1945, against a Wehrmacht supply depot hidden in Reichswald Forest. 8 P-47s, each carrying one napalm tank and one 500-pound high-explosive bomb, created a firestorm visible from 20 miles away, destroying approximately 3 acres of concentrated supplies in a matter of minutes. The months from March through May of 1945 witnessed the P-47 at its evolutionary peak. The P-47M variant, capable of 470 miles per hour, entered operational service with performance matching early jet fighters. The P-47N, specifically designed for the Pacific Theater, demonstrated a combat radius of 2,350 miles while still carrying bombs, enabling strikes against targets that had previously been unreachable. But it was tactical employment rather than technical specifications that truly demonstrated revolutionary warfare. P-47s now operated as forward air controllers, directing other aircraft to targets, as artillery spotters for ground forces, as photo reconnaissance platforms, as communication relays, as psychological warfare platforms dropping propaganda leaflets, and as emergency supply deliverers to surrounded units. The same aircraft type could perform 6 different mission categories in a single day, depending on what was needed. This flexibility multiplied combat effectiveness beyond anything that could be achieved by specialized aircraft dedicated to single roles. The comprehensive statistics documenting P-47 operations throughout the war defined the magnitude of this revolution in military aviation. Production figures told one part of the story. 15,683 P-47s were built, making it the most produced American fighter aircraft. Republic's Farmingdale facility produced 9,086 aircraft. Republic's Evansville facility produced 6,242 aircraft. Curtiss Wright's Buffalo plant produced 354 aircraft. Peak daily production reached 35 aircraft. Unit cost decreased from $105,000 in 1942 to $83,000 by 1945, despite continuous improvements in capability. Combat operations statistics documented the scale of P-47 activities. Total sorties flown exceeded 746,000. Combat losses totaled 3,499 aircraft. Non-combat losses totaled 1,723 aircraft. Loss rate per sortie averaged just 0.7%. Air-to-air kill ratio achieved 4.6 to 1. The amount of ordnance delivered was staggering. Bombs dropped totaled 132,000 tons. Rockets fired totaled 135,000. 50 caliber rounds fired totaled 119 million. Confirmed destruction in the European theatre painted a comprehensive picture of the P-47's effectiveness. Enemy aircraft destroyed in air combat exceeded 3,200. Locomotives destroyed totaled 9,000. Railway cars destroyed totaled 86,000. Motor vehicles destroyed totaled 68,000. Armoured vehicles destroyed totaled 6,000. Horse-drawn vehicles destroyed totaled 60,000. These numbers represented not just tactical victories, but strategic paralysis of German military capabilities. The P-47's evolution fundamentally changed how military strategists thought about air power. Pre-war doctrine had rigidly separated strategic and tactical air power into distinct categories. Heavy bombers attacked strategic targets like factories and oil refineries. Fighters achieved air superiority through aerial combat. Attack aircraft provided ground support. These were separate missions requiring separate aircraft types. The P-47 demolished these rigid categories, proving that a single aircraft type could merge these roles and achieve strategic effects through tactical means. The destruction of transportation infrastructure by P-47s accomplished what years of strategic bombing against industrial targets had struggled to achieve. By April of 1945, German forces couldn't move during daylight hours without facing immediate attack. Supply lines ceased functioning effectively. Reinforcements couldn't reach front-line units. Tactical attacks, accumulated over months, had achieved strategic paralysis. The United States Strategic Bombing Survey, which analyzed the effectiveness of Allied air campaigns after the war, concluded that fighter-bomber operations, primarily conducted by P-47s, reduced German rail traffic by 75% in forward areas by March 1945. This transportation paralysis contributed more directly to German defeat than the destruction of industrial targets by heavy strategic bombers. The P-47's success forced fundamental changes in military doctrine that would shape air warfare for decades. The United States Air Force's first official doctrine manual, published in 1947 after the service gained independence from the Army, stated explicitly that the artificial distinction between fighter and attack aircraft had been rendered obsolete by wartime experience. All fighters must be capable of ground attack. All attack aircraft must be capable of self-defense. This represented a complete reversal of pre-war thinking. The 1935 Army Air Corps Manual had stated that pursuit aviation's sole purpose was achieving air superiority through aerial combat, and that diversion to other roles weakened this primary mission. The P-47 proved conclusively that mission flexibility multiplied combat power exponentially. A fighter that could only fight was half as valuable as one that could fight and bomb. This lesson shaped every subsequent American fighter design. The revolutionary concept pioneered by the P-47 proved so successful that it shaped post-war aircraft design globally, influencing not just American developments, but international aviation thinking. When the Korean War erupted in June of 1950, the P-47's direct descendants, F-84's Thunderjets and F-86 Sabres, configured as fighter bombers, dominated tactical air warfare in that conflict. The multi-role fighter concept pioneered by the P-47 had become standard doctrine for air forces worldwide. Republic Aviation's transformation of the P-47 represented American industrial capability at its peak performance level. The company's founder and chief designer, Alexander Kartveli, had designed the aircraft with exceptional strength margins that far exceeded formal requirements. When the Army Air Forces requested an aircraft capable of withstanding 6G maneuvers, Kartveli built one stressed for 12G loads. When they wanted capability to carry 500-pound bombs, he provided structure capable of handling 2,500 pounds. This deliberate over-engineering allowed field modifications that transformed the aircraft's capabilities faster than formal design changes could have achieved through normal channels. The P-47s leaving Republic's assembly plants in 1945 incorporated hundreds of improvements derived directly from combat experience and pilot feedback. Yet production never stopped for major redesign programs. Continuous incremental improvement kept the assembly lines running while simultaneously improving the product. The production statistics revealed the industrial miracle this represented. 48 months of continuous production without major interruption. 15,683 aircraft delivered to operational units. 28 major variants produced. 430 field modification kits developed and distributed. Peak production of 35 aircraft daily. 2 plants operating simultaneously with coordinated production. Cost reduction of 27% despite continuous capability increases. This represented industrial efficiency that Germany, despite its engineering prowess, simply could not match. The P-47's fighter-bomber concept directly influenced every subsequent American combat aircraft design. Direct descendants included the F-84 Thunderjet, a jet-powered continuation of the P-47 concept, the A-10 Thunderbolt II, explicitly named after the P-47 and carrying forward its ground attack mission focus, and the F-105 Thunderchief, a strategic fighter bomber extending P-47 philosophy into the supersonic era. Conceptual inheritors included the F-4 Phantom II, where multi-role capability was central to the design from inception, the F-16 Fighting Falcon, a lightweight fighter that evolved into perhaps the premier fighter bomber of its generation, the F-15E Strike Eagle, an air superiority fighter adapted for strike missions, the F-18 Hornet, designed from the beginning as a dual-role fighter attack aircraft, and the F-35 Lightning II, representing the ultimate multi-role aircraft intended to replace multiple specialized types. The P-47 established the template that all these aircraft followed. Build strong, build adaptable, and let operational requirements drive capability evolution rather than trying to predict every possible use in advance. The comprehensive training program developed for P-47 fighter-bomber pilots established standards that are still followed by air forces today. Modern fighter pilots train for air-to-air combat, air-to-ground attack, reconnaissance, and electronic warfare, a multi-role approach pioneered by P-47 squadrons during World War II. The 200-hour pre-combat training requirement established for P-47 pilots became the baseline for post-war air forces globally. The emphasis on instrument flying, formation tactics, and weapons delivery accuracy established professional standards that defined modern military aviation. Luftwaffe General Adolf Galland, who commanded Germany's fighter forces during much of the war, provided perhaps the most telling assessment of the P-47's impact in his post-war memoirs. He noted that P-47 pilots demonstrated not just technical proficiency, but remarkable mechanical reliability. The aircraft required minimal maintenance, experienced few mechanical failures, and had virtually no oil leaks, unlike German aircraft which constantly suffered maintenance problems. This reliability multiplied effectiveness because aircraft that could fly 3 missions daily achieved far more than technically superior aircraft that spent most of their time undergoing maintenance. Statistical analysis supports the testimony of veterans from both sides. By war's end, the Luftwaffe could muster only approximately 100 operational fighters on any given day. This wasn't primarily due to lack of aircraft, as German factories continued producing fighters until the final weeks of the war. The limitation was fuel, operational airfields, and logistics, all destroyed systematically by P-47s and other Allied fighter bombers. The fighter bomber had achieved what strategic bombing couldn't accomplish: complete paralysis of enemy operations through infrastructure destruction. The P-47's fighter-bomber capability provided extraordinary economic efficiency compared to traditional strategic bombing approaches. Cost per ton of bombs delivered told a revealing story. B-17. Flying fortress operations cost approximately $28,000 per ton delivered. B-24 Liberator operations cost approximately $24,000 per ton. P-47 Thunderbolt operations cost approximately $4,200 per ton. Crew losses per 100 tons delivered painted an equally stark picture. B-17 operations resulted in 8.5 aircrew casualties. B-24 operations resulted in 7.2 aircrew casualties. P-47 operations resulted in 0.9 pilot casualties. Support requirements per ton delivered completed the efficiency comparison. B-17 operations required 47 ground personnel. B-24 operations required 39 ground personnel. P-47 operations required 8 ground personnel. The mathematics were undeniable and unforgiving. P-47's delivered destruction at 15% of the cost and 10% of the manpower investment required by heavy strategic bombers. The fundamental difference between German and American military philosophy manifested clearly in their response to the P-47. German military doctrine, rooted in centuries of Prussian military tradition, favored specialized excellence within narrowly defined roles. The best fighter should be optimized purely for air combat. The best bomber should be optimized purely for bombing. The best ground attack aircraft should be optimized purely for that mission. American military doctrine, shaped by pragmatic industrial considerations and resource efficiency, emphasized adaptability and operational flexibility over narrow specialization. The P-47 proved that in modern industrialized warfare, flexibility beats specialization. An aircraft that performed 6 different missions adequately was vastly more valuable than 6 specialized aircraft, each performing 1 mission perfectly. When Luftwaffe pilots encountered P-47s over Eindhoven on September 17, 1944, during Operation Market Garden, they faced not just an aircraft, but a revolution in military thinking. Those heavy, supposedly clumsy interceptors they had dismissed in 1943 had evolved into the primary instruments of their destruction. Not through superior performance in any single role, but through unprecedented versatility that allowed them to adapt to any tactical requirement. The P-47's combat record in the European theatre from 1943 through 1945 stands as one of the most successful in aviation history. Aircraft performance statistics documented its capabilities. Maximum speed of 433 miles per hour for the P-47D. Maximum speed of 470 miles per hour for the P-47M. Combat radius of 450 miles with drop tanks. Service ceiling of 43,000 feet. Maximum bomb load of 2,500 pounds. Production excellence demonstrated American industrial capacity. Total built, 15,683. Monthly peak, 1,050 aircraft. Cost reduction, 27% over the entire production run. Variants produced, 28. Field modifications, 430 plus. Combat effectiveness statistics told the story of tactical dominance. Sorties flown, 746,000. Loss rate, 0.7% per sortie. Kill ratio, 4.6 to 1. Bombs dropped, 132,000 tons. Ground targets destroyed, over 224,000 confirmed. The story of how the Luftwaffe never expected P-47s to carry half a B-17's bomb load illuminates a profound truth about military innovation and adaptation. The Germans, who were masters of specialized technical excellence, failed to anticipate that the Americans would deliberately blur the traditional lines between fighter and bomber, creating an aircraft that excelled not through perfection in one narrowly defined role, but through competence across all roles. The P-47 Thunderbolts' evolution from high-altitude interceptor to devastating fighter-bomber didn't just surprise the Luftwaffe. It revolutionized air warfare in ways that continue to influence military aviation today. Every modern combat aircraft flying today, whether American, European, Russian or Chinese, incorporates fundamental lessons learned from the P-47's wartime transformation. The heavy fighter that supposedly couldn't turn with a Messerschmitt became the aircraft that helped turn the tide of World War II in the skies over Europe. In the final analysis, the 7-ton fighter that the Luftwaffe dismissed as too heavy to matter became the instrument of their destruction. Not through superior performance in aerial combat, though it proved formidable enough in that role. Not through superior bombing accuracy, though it could strike with precision. But through superior adaptability, the ability to perform any mission, carry any ordnance, attack any target, and prevail in any engagement. The P-47 proved conclusively that in modern warfare, the victor is not necessarily who fields the most specialized or technically perfect weapon, but rather who adapts fastest to changing tactical realities and exploits opportunities that others fail to recognize. The Luftwaffe never expected P-47 Thunderbolts to carry half a B-17's bomb load because such capability violated every principle of their rigid doctrinal understanding about how air warfare should be conducted. Fighter aircraft fought other fighters. Bomber aircraft bombed targets. These were separate roles requiring separate platforms. That fundamental failure of imagination, that inability to conceive of an aircraft that could seamlessly transition between roles, cost them air superiority over Europe. It cost them mobility on the ground as their transportation infrastructure was systematically destroyed. Ultimately, it cost them the war. The P-47's transformation from fighter to fighter bomber remains history's clearest example of how tactical adaptation driven by operational necessity can achieve strategic revolution. It demonstrates how failure to recognize revolutionary change, even when that change is happening right before your eyes, can doom even the most professional and experienced military force to devastating and irreversible defeat. The lessons learned from the P-47's wartime service continue to shape military aviation doctrine 7 decades later, ensuring that this remarkable aircraft's legacy extends far beyond its impressive combat statistics into the fundamental principles that govern how modern nations think about air power and military aviation.